Okay, I think now's probably a good time to start. So just Sri, can you hear me okay? So can anyone hear me?
Yes, yes.
Yep.
Yep,
Okay.
loud and clear.
All right, good. So let's get started. So yesterday we went through the BACnet network. Now, before we go on to do Modbus, is there anything about the BACnet network stuff we did yesterday that I need to go over again or clarify? All right. So the BACnet networks are very easy to use. They have the network itself has a the BACnet protocol gives you the choice to be able to go out and discover devices and discover their points, which makes it very easy to use and easy to find points online. And also, if in the offline situation, we can use the CAF file to import points. Now, when we go over to Modbus, Modbus is a much older standard protocol, and it doesn't have the ability to discover devices or to discover points. So everything you do in a Modbus network, you have to do essentially manually. Okay. Now, the first thing to do is to actually get your Modbus network set up. So we have a Modbus async network defined in this station, and that was because when we did tools, new JCI station, we went through the choices and we chose to have Modbus. So if I just refresh your memory, we went into here. So in our new station wizard, we got to choose that we had a BACnet, MSTP and IP networks. And then we got to choose Modbus RTU. So we chose one RTU Modbus network. And we made that selection there. And that's what we're seeing over here, our Modbus async network. Okay, so that name that's there is the name that appeared over here. Yeah, so we won't go through the new station wizard anymore. So this is what we got. So this is our Modbus async network. So async means asynchronous, which is another way of saying Modbus RTU, which is another way of saying Modbus using RS485 communication. Okay, so electrically, it's the RS485 electrical standard. So it's the same electric standard that Modbus, that BACnet MSTP uses, and what N2 bus uses. So the electrically, it's the same. It's just the messages that are different. Okay, and just because Modbus N2 and BACnet MSTP, they're all RS485 protocols, but you can only have one protocol defined on a trunk. Okay, you can't mix Modbus and N2 on the same cable. You can only have one protocol, one of those three protocols on a cable. Okay, so this Modbus async network, we could rename it and call it, say, Modbus O1. Whatever makes sense for our project. We can right click and view the AX property sheet for that Modbus protocol. And the first thing we have to do is set up the serial port. Okay, so this is the physical port that we're going to communicate on. Okay, so for that we need a port name, and that'll be COM2. So we're using the second COM port on the FX80, the second RS485 port on the FX80. It could be COM3 or 4 or 5 or 6, but if it's 3, 4, 5 or 6, then we have to be using the expansion module to get those additional ports. So COM1 is the first RS485 port, COM2 is the second. Okay, we're using COM2. The next thing we need to nominate is the baud rate, and any of these available baud rates can be used. 9600 is a fairly standard baud rate for Modbus, but it could be any of these, and the baud rate will be dictated to by the device that you're connecting to. So the device you're connecting to will have a baud rate, and you have to match that baud rate. And the other thing that's important is that every device on the trunk has to be operating at the same baud rate. So early in the project, you have to decide what baud rate you're going to use and make sure that all of the Modbus devices are configured for that baud rate. Okay, so we're choosing 9600. 8, 1 and none is fairly standard for the data bits, stop bits and parity. Again, that has to match what the field device you're connecting to, what it's got as its data bits, stop bits and parity. And the same rule applies. Whatever, all devices have to have the same set of parameters, data bits, stop bits and parity. And likewise the flow control as well. So those 4 points all have to match on all devices on the trunk. Okay. The next setting is the Modbus data mode. And RTU is the standard, but there's also an option for ASCII. ASCII is very rare, but it essentially means sending the same messages, but sending them as readable ASCII characters rather than raw data, which is RTU. So nearly always Modbus will be RTU. Okay. Sniffer mode is used if you need to try and work out exactly what's going on. So you rarely need to actually use sniffer mode, but it's there if you need it. So we make those changes and we save. We're seeing a fault up here saying could not enable Modbus serial communication. Okay, so that's just because on my laptop I don't have COM2 available. Okay, but on an FX80 you would not get that error. Okay, but we can still keep on keeping on, and that's our Modbus network setup. The next thing to do is start creating some Modbus devices. Okay, so if I double click my Modbus network, I've got my Modbus async device manager view. Okay, and it's showing some devices I've already created. And if these devices are sitting directly underneath the Modbus network. See those 3 devices there? Each device has a name and points. Okay, and the same as with BACnet, I can create folders if I want to, and I can create some structure to my Modbus network. So if I wanted to make a folder, it's important that I choose new folder from within inside this device manager. Okay, so if I said new folder, and again I could go building A, and then underneath building A, I could create a folder called level 1. Okay, and then under level 1, I can start creating devices. So just say I create a new device. I click new, and I get the option to add a Modbus async device energy meter from Johnson Controls. So Johnson Controls North America sells a Modbus energy meter, and they've set up a template so that you can just select that meter, and I can add it. I can add one meter, add address number 1, go OK, give it a name like let's call it house power. The house power meter, which is on level 1. I go OK, and I've just created a level 1, a power meter with a whole heap of points. Okay, so that's how easy it is if you have a template already set up. But that's where, unfortunately, we only have that set up for one type of power meter. Okay, so without that template, we go back to level 1, device manager, and we go new. We're just going to add a Modbus async device. Okay, so this is just a generic device. We're going to add one device starting at address number 2. Okay, so this is my first device, and just say it's a fan coil unit. All right, fan coil unit, Modbus async device at Modbus address number 2. So somewhere on that field device, there'll be a way to set the address. Okay, either through the display or with dip switches. There'll be some method for setting the address, and the address will be somewhere in the range 1 to 247. It might be less than that, but Modbus supports 247 addresses. Okay, in this case, we've chosen address number 2. Then there's some other parameters here which we'll talk about later. There's a pole frequency, and then there's a ping address. And again, yeah, so the ping address is the register in the controller that we're going to read in order to see if the controller is online. Okay, so the way the Modbus protocol works is that there's some very simple messages. There's a read register message, and there's a write register message. So when you read a register, you're just reading a memory location in the controller. And you have a starting address and the number of registers that you want to read. So you can say, starting at register 5, I want to read 10 registers starting at address 5. Okay, that Modbus message will get sent to the slave device. The slave device will reply back with the contents of those 10 registers, starting at address number 5. Okay, now to see if the device is actually out there and listening, you can just read one of the registers, and if there's a device there, it'll reply back. Okay, so you can pick a register to read as your ping address register. So that's the register you're going to read just to see if the device is out there and working. If you get a reply back, it tells you that the device is online and ready to receive data. Okay, so when you nominate an address in Modbus, you can nominate it as a hexadecimal number starting at 0, or as a decimal number, again starting at 0, or you can use the Modbus convention, which is something like 4001. Okay, here we go. So I've just created a device at address number 2. And here he is under level 1. If I expand it out, I've got some various parameters, but the main thing I've got is a folder called points. And at the moment, there's nothing defined under points. All right. So in order to add points to this fan core unit, I double click and I get to add a new point. So there's no discover option because Modbus doesn't support discover. Okay, all I can do is go new and choose what sort of point do I want to map or create. So the simplest point to create is a numeric point. So I'm just going to read a number out of the controller. So a numeric point. And then it says, what's the address? What's the register for that point? And at this point, you've got to have a register map. Okay, so whoever manufactured this Modbus device has to publish the Modbus mapping table or register table for that device. So for example, we have a T7000 thermostat, Johnson Controls T760 thermostat. Now we published the thermostat Modbus data table where we talk about the specification. So in here, the data format, 8.1 and no parity. So that tells us that information. It says what function codes do we support. So if we send a Modbus request, these are the function codes that we can send. So 1 means read coil, 3 means read register, 4 means read an input, sorry, a holding register for 3, 4 is an input register, 6 is to write to a holding register, and 16 is to write to multiple holding registers. Okay, so that's what the various function codes mean. And then we move down to the function 1 registers that we can read. and the function 4 registers that we can read. So function 4, register number 1, is the model number of the device. Register number 2 is the room temperature. Okay, so let's say we want to map the room temperature. So we go back to our control, our numeric point, and we're not using Modbus notation, we're using decimal. And we go back to our device, and it's the number 2, okay? The decimal 2. What's the data type? Okay, so we go back to our table. It just says room temperature, and there's a little note there saying note number 2. We scroll down here, down, 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 somewhere here. We see 2. All temperature expand 10 times, such as 26.5 is 26.5 times 10 is 265. So that what they're saying there is that if the temperature was 26.5 degrees, the controller will reply back with the integer 265. Okay, and it doesn't talk about plus or minus, it just says 265. So from that, we assume that the type will be an integer type. Okay, we choose integer type and we go OK. Now we get into the details of this particular point. So we're going to call it the zone temperature. It's a numeric point. It's enabled. The tuning policy will leave as the default. The pole frequency. How often do we want to read this value? Do we want to read it fast, slow, or normal? Okay. So for pole frequency, leave it at normal, unless it's a particularly important point, like a fire alarm or some other point where you want to have a fast response. If you set all of your inputs to fast, there'll be no benefit at all. So with Modbus, you poll the device, you read the points, you poll the next device, you read the points, you poll the next device, you read the points. You work your way through all of the devices, then you start back at the beginning. So if you've got a lot of devices, it takes a long time to get through all of them and read all of their points. So the performance is what it is. There's not much you can do to make a Modbus trunk any faster than what it is. Okay. If you choose, so the idea of the fast polling is that if there's 1 or 2 points on that trunk that you're really interested in, and you really want to see fast changes of state on those inputs, then you can choose fast, which means that those registers will be polled more often than any other registers on the network. And likewise for slow means that those registers will be polled less often. Okay, so you might use slow for something like the set point, which doesn't change very often, and you might use fast for a fire alarm or an after hours request or something where you want to see a quick change of state, and then everything else you'd leave as normal. Or better still, just leave everything as normal. Okay, so that's the pole frequency. Your 3 choices: fast, normal, slow. Now we've got the address of the point, and we chose decimal 2. And that was because in our mapping table, we've got the number 2 for room temperature. Okay. Now this is where the first problem that you have with Modbus is that it's not a standard. Modbus is a standard protocol, but the way to define the Modbus mapping table, that's left up to each manufacturer how they define it. And so in this case, it turns out that we need to subtract the number 1 from these addresses. So address number 1 is actually address 0. Okay, and address number 2 is actually address number 1. So instead of starting at 0, which is what actually happens at the low-level Modbus, Modbus is 0 based. So the first item, the first register is register 0. Second register is register 1, 2, 3, 4, and so on. But it starts at 0. So often, when you see address 1, you have to have in the back of your mind that might actually be register 0. Okay. And this one, from experience, from testing, we've established that address 1 in this table means register 0. And address 2 means register 1. Okay, so let's go back to here and let's change that to 1. Register type is...
David?
Yep.
That is that not mentioned in our documentation?
I don't know. It's a common situation. So,
all right.
Yep. It's every time you do a Modbus integration, every time you look at a Modbus table, there is always a doubt as to whether that is 1 or 0. Whether it's starting at 1 or is it starting at 0.
Right.
Okay, so that's just a fact of life with Modbus. And you might be able to read something here that tells you that. I don't think so. Yeah, I don't think there is in this instance. I don't think there's anything in here that explains that. Okay. Now this is function number 4. Function number 4 is read input register. Okay, so when we go back to our, it's an input register, not a holding register. Okay, so we put decimal 1, input. The data type is integer. We established that before. And we go OK. So we've now mapped the point. Now, if I was on site and connected to this Modbus network and this Modbus device, I would get a reply back and I would start seeing the value displayed here. And with Modbus, the sooner you can get connected to a Modbus device for the first time and get a reading here, the better. So if you have a Modbus project where you're integrating Modbus devices, the first thing you ask for is the register map, the Modbus mapping table or the Modbus register map, and you ask for that and you chase that and you chase it and you chase it, and you make sure you have it in your hand before you start doing anything, because without that table you can't do anything. All right, as soon as you've got that table, you have to read it and understand it. You got the document from the supplier, from the manufacturer. You have to read it and understand it, and it might be crystal clear. They might make it really obvious that when they say 0, they mean 0, and when they say 1, they mean 1. Or it might look like this table, where it starts at address 1. And that's a red flag that says, well, is that really address 1 or is that address 0? Okay, and you can read the document over and over again. You can ask people, you can ring up the manufacturer, and he might tell you, or he might not, or he probably doesn't know. But this, you won't know until you've actually connected to the device and you get a value back, and only then will you be certain that you've interpreted this document correctly. And you'll know because you'll get back a value that looks like a zone temperature. Okay, and so we would get back, if it was 26 degrees in the space, we would get back the number 260. So if it was 26.5 degrees in the space, we would get the number back 265. Okay, if it was 26 degrees, it would be 260. If it was 22 degrees, it would be 220. Okay, and so at this point, we're connected, it's working, we're seeing 265 as the number. Okay, so how do we turn 265 into 26.5 degrees? And for that, we right-click and view the property sheet. And this is the property sheet for our Modbus point. We expand it, and we see the option here for conversion. Okay, if conversion is default, it means that whatever number we read is the number we display. We can change that to linear, which means we then multiply whatever we read, we multiply by this, and we add this offset. So to turn 265 into 26.5, we multiply by 0.1. Okay, we save that. If we're connected to the device, it'll start displaying here the value 26.5. Okay, so that's where the conversion comes in. Okay, and that's a very common conversion in Modbus. A lot of things, particularly temperatures, are sent through as an integer, and you divide it by 10. Okay. So that's our zone temperature done. Okay, so we're on site, we've connected to the zone temperature, and we're seeing a value that makes sense. All right, so now we know that that's the room temperature. If we wanted to get the room set point, we would have to go to 7, which is actually 6. Okay, and the function code 0306 or 16 means that 6 or 16 means that you can write to the holding register. Okay, so you can read the holding register or you can write to the holding register. So that means we can write to the set point. Okay, so let's create the set point. We go back to our points and we go new, and this time we choose numeric writable. Okay, starting address is decimal. It said 7 in the table, but it's really 6, and it's an integer type, and we go OK. That's it. We call it set point. It's writable, it's enabled, pole frequency is normal, address is that, type is that. Conversion, we can set the conversion in here. So the same conversion is used. We multiply it by 0.1. Okay. Now we've created a set point. We can right click that set point and we can write a value to it like 24 degrees. Okay, if I right click on here and view the property sheet, you'll see what's happened here is that I set the value to 24 and we wrote that value 240 down to the device. Okay, so it works backwards. When we put 24.0, the right value is 240. Okay, now that write failed because there's no device out there, and the output that we see is left at 0 because the read value is 0. So whenever we have a writable point, we display the read value, which is the actual value in the controller. So when we write to it, we send the write command and then we read the value back. And if the write command is successful, then the value we read back will be what we just sent down. So the output is always what's actually in the controller. And so if the read value doesn't match the write value, it's because the write was not successful for whatever reason. In our case, it's because there is no device out there. Okay, so that's our numeric writable point that we've created for the set point. Okay, now both of these are displaying 0.0. These are both temperatures. So how do we get it to display degrees Celsius? All right, so if I look at my property sheet, in here I've got a thing called facets, a property called facets. And if I click on this double arrow, I get to configure those facets. And the first facet is the units. So I click on this button and I choose temperature out of this list. Temperature. And then I choose my units of Celsius. Okay. Then I've got precision, which is the number of decimal points am I going to display. So I'm going to have 1 decimal point. So my precision is 1. If I wanted to have a limit for the minimum and maximum values, and for this Modbus device, 0 will be the minimum because it can't go below 0 because it's just an integer, a whole number, and without any sign on it. So 0 is the smallest it can go. The biggest number is pretty big, so we won't worry about that. We'll just leave that as plus infinity when we go OK. If we save that, now when we go back, it says 0.0 degrees Celsius. So that's what the facets does. It puts the units on the point. Same for the temperature set point. We go. We could do it via the edit screen, or we can do it via the property sheet. So our facets, we can go here and set them up, or we can choose this icon here, which will list all of the recently entered facets that I've used. So the last thing I did was I did degrees Celsius precision 1, which is the one I just did before. It's sitting there at the top of the list. So rather than go in and longhand do it all again, I can click on this option and pick the first one out of the list, and it's made those changes. So rather than go through here, I can just click and choose the last one on the list, or the most recent one. Okay, I save that. And now my output, if I refresh it, is showing as degrees Celsius. Okay. So that's facets. Okay, so I go back, degrees Celsius, set point. Okay, so if I go and look at my mapping table again, so I did my room temperature. Now I've got an occupancy status. Okay, so I'm going to be occupied, and it's either going to be 0 or 1. So the number 0 means unoccupied, the number 1 means occupied. Okay, so if I want to add the occupancy, then let's go back and try that. So I'm going to add a new point, and I could go a Boolean point, or I could go an enum point. So Boolean is either true or false. An enum can be 2 states, or it can be 3 or 4 or 5 different states. So low, medium, and high would be an enum, or enumerated point, with 3 states. So I'll choose enum, bits point. Okay, so I choose that, and its decimal address, and just refresh my memory, occupancy 3, but really that's 2. Okay, so I put decimal 2. And I'm going to choose an integer type, and I go OK. So the name of the point will be occupancy. Its type, the address is 2. Type is integer. And then we're going to read. So when it reads the register, it gets it as 16 bits, 16 ones and noughts. Okay. It turns out that if it's 0, all those bits will be 0. If it's 1, then bit number 0 will also be 1. So I'm going to read 1 bit starting at bit 0. Okay, and if I choose OK for that, I've now created my occupancy point. Now, if I look at my property sheet, I'm reading 0 at the moment. If it was on, I'd be reading the value 1. Now here, in my facets, I get to display what the different states are. So if I click on this arrow here, I can define a range which says the number 0 was unoccupied. Okay, I add that to my list, and the value 1 was occupied. And I add that to my list, and I go OK, and OK, and OK. So I've set up this little mapping table that says 0 is unoccupied, 1 is occupied. And if I look back at my document, 0 is unoccupied, 1 is occupied. All right. If I save that and I refresh it, now instead of displaying 0, it displays unoccupied. Okay, and if we look here in our drop-down list, my latest facet that I've set up is unoccupied and occupied, and then so I don't have to go through all that painting. The next time I just have to select it out of this list. Okay, I go back, that's my occupancy. All right. Now I've got an error code, so I could map that if I want to, or I could choose not to. I can map the power, whether I'm cooling, heating, or ventilation. So let's look at that one. So the mode is at address 6, which is actually address 5, and has the values 1, 2, or 3. All right. So that's going to be similar to occupancy. So I could go new, or I could just go to my occupancy and go right-click and duplicate. And I want to call it the mode, cooling, heating, ventilation. Let's go back. It's the mode. There it is. And if I view the AX property sheet, now back at our document, it's got the value 1 for cooling, 2 for heating, 3 for ventilation. So there's also a 0 would be undefined, right? So it's got the values 1, 2, or 3. So you can represent that with 2 bits. All right, 0, 0, 0, 1 for 1, 1, 0 for 2, and 1, 1 for 3. So if we go back here, we're beginning at bit 0, but this time we're going to read 2 bits, not 1. Okay, save that. And our range is going to be 0 is probably safely call that error because 0 is not one of the numbers we're expecting. And we modify that. We go to number 1 and we change it to cooling, heating, ventilation. Change that to cooling, modify. 2 will be heating. We add it to the list. And 3 will be ventilation. We add it to the list. Okay. Now we go OK, and OK, and OK. Now we've got this range here. We can save it. And when we refresh it, it comes back as error because that's what you get when you see a 0. If we were online to the controller, we wouldn't be seeing 0. We'd be seeing the number 1, 2, or 3, in which case it would be cooling, heating, or ventilation. Okay.
David, I've got a question.
Yep.
For the mode, it is also a writable point, right? But
let's see. Let's have a look.
Because it says 6 and 16.
Yeah, it is. It's writable.
But we copied the status point, which is only a read point.
That's right. So what we've done, if we wanted to make it writable, which would be fair enough. So if we double click this, we can't change the type. If we look at the property sheet, we can't change the type. So the only option is to create a new point as enum bits writable. Okay. At Modbus address number 2. Was it 2? No, it's that was the other thing we didn't say. It should be 5, yeah. It says 6, but it's really 5. And we go OK. Oh, sorry. It's not Modbus 5, it's decimal 5. And number of bits is 2. The facets will be what we just set up previously, like that. And we go OK. And now we've got a writable point. We can delete this one, get this one, rename it to mode. Okay, and now if I right click, I can go action set, and I can set it to the value heating and go OK. It still says error, but if I look in my property sheet, you can see I've sent a right value of 2, but I'm still reading back the value 0. Okay, and that's because heating gives me the value 2, and I've commanded it to heating. Okay, so this is all fairly painful and slow, but once you've sort of worked it out, it's not that slow. But you do need to, as soon as you can connect, the sooner you can connect to a device and confirm that what you think is right, so that you're starting to read values and get the value back that you expect, then the better. So if we go up here, I've already gone through all this pain and created a fan coil unit called T7600 address number 4. And if I look at his points, these are all the points. Okay. And so things like the keypad lock, I can right click, action, and lock all, lock the fan and the set point, on, off, and the clock, unlock just the on, off, and so on, right? So 1, 2, 3, 4, 5 different options. If I look at that, as a property sheet, I can see that this is my range. The 0, 1, 2, 3, and 4. And if I'm looking at register 17, if I look in my table here, 17 is actually 18, and the key lock, and there are my 5 different choices. Yep. So once I've done that for one, I can right click and copy, and then I can go down to level 1 here, and I can right click and paste and call it FCU 02, and there it is with all of the points, and away I go. So it's painful to do the first one, but once you've got it, you can quickly do the rest. Yeah. And then once you've done one, once you've done it on this project and you want to do it, use that same controller on the next project, what you can do is right click on this fan coil unit I've created here, right click, copy, go up here to my C drive, just pick a directory, in this case JCI bog files, and if I right click I can paste. All right, so just now I pasted it into this directory, and it's sitting there as a file called fcuo2.bog. Okay. And funnily enough, in here I've got T7600 004 bog. So that's where I got the one that I showed previously, yeah? If I wanted to go to my next project and use this one, I can right click, copy, then I can go down to my level 1, right click and paste, and instead of fan coil unit number 2, I'll call it fan coil unit number 3, and there it is, and there's all the points. So it feels like it's hard work and it's slow, but once you've put in the hard work, worked it all out, you can then copy it off as a bog file and use it over and over again. Okay, and typically on a Modbus project or a Modbus network, you'll have many devices all with the same mapping table. So you'll have 20 power meters, all the same with the same mapping table. Okay, and from a estimating point of view, if a project says we've got a Modbus trunk, the question to ask is, what's on that trunk? Is it 50 power meters, all of the same brand, all of the same model? In which case, you've got one mapping table to decode and work out and solve and create, and then you copy it 49 times and your job's done. Or is there 3 power meters, 2 transfer switches, 5 fan coil units from vendor A, 7 fan coil units from vendor number B. Now you're up to 3 or 4 different mapping tables that you have to read, interpret, create. So your job just got 4 times bigger because you've got 4 different devices that you have to integrate into Modbus. Now this is all of this hard work is because it's Modbus. There's nothing, this is actually a very easy way to configure Modbus points. All right, and the good thing is that when you're connected to the device, you create this point, straight away you will see the value and you can tell whether you've got it right or whether maybe you've got it wrong and you need to do some more work to try and work out, am I got the right register? Should it be 0 or 1? Or or is there something else I have to fix? Okay, so if you're mapping in a power meter, a good thing to concentrate on is the register for the line to neutral voltage. So if you map that in and you get the number 240, you know you've probably got it correct. Or if you got 238, it's probably correct. Or 245. But if it's 2040 or 2400, then you know you have to divide by 10 and so on. So if you've got a device you're trying to map, pick a register where you know what the expected value will be. Another good one is the frequency. For a power meter, you expect frequency to be about 50 hertz or 49.9 or 50.7, something close to 50. So if you can set it up and get a reading of 50 or thereabouts, you know you've got it right. And once you've got one point mapped correctly, you can use that as your guide to set up the rest of the points. Okay. So is there any questions on any of that?
Yeah, I've got some questions.
Yep.
The first question is, so the ping hex could be anything.
So the ping, yes. So in the device here, when we set up the device and look at the property sheet for that device, we have the ping address. And in this case, it's decimal 1. So normally it would be one of the registers that you're reading. So number 1 was the room temperature. And so pinging number 1 is a good choice. Okay. And so, yeah, it should be a valid register. But even if it's not a valid register, you should get a reply back from the device that says you're reading an invalid register, and we take any reply to be the device exists and it's out there and it's responding, so it's online. Yeah. So the ping address is typically the first point that you map as a general rule.
All right.
Yeah.
The next question is, so the BOC file is actually equivalent to the VMD file in the Metasys world. Is it?
It's a bit more than that. So basically, a BOG file is a really good thing. So the other day up here we did building A with all of this stuff on it, right? We can take building A here and go right click, copy, and I can go up to my C drive, BOG files, and I can go right click, paste. All right, and I've copied everything from that node down. So I've got a BOG file called building A. If I right click, copy that BOG file, go to my backnet network because it has to go under the same parent that it came out of. So if I go to my backnet network and right click and paste, and I call it building D, go OK. Let's come in as building 1A, but so I might not have typed that right, but there it is. It's copied in all of that, all of those devices, all of those points, all of it was bundled up in that BOG file, and I can rename it as building D. Okay, so a BOG file lets you copy basically anything in a JSON that you want to make a copy of. You can copy it as a BOG file and then use it again later. The only requirement is that if I was to try and put building B underneath a Modbus network, right? If I right click and try and paste building BOG file under Modbus, if I go OK, it didn't work because it's an illegal parent. It's expecting the parent, it's got a parent of, this has got a Modbus parent, whereas what I tried to paste is expecting a backnet parent. Okay, so yeah, a bog file is similar to the VND that we have in Metasys, but it's a lot more powerful than that. Okay. Yeah. So what else? And the other good thing about Modbus in Facility Explorer is that you can do the mapping in Facility Explorer. In Metasys, you have to go out into a separate application, which you might not even have, and create the VND file and do all that problem solving in the VND file, then take it to site, put it in, and it'll either work, which means you got everything right, or something will be wrong, in which case you have to go back, work out what you did wrong, make the changes, send it back out, try again. So this is a much more flexible, quicker way to do it. Okay, and once you've got the first device done, you can then copy it off as a bog file and then do it again and again and again. Or if it's on the same project, you can just right click and duplicate it as Fancore unit number 4 and so on. Okay.
Right. I've got another question.
Yep.
Let's say we don't have an FX80 yet and we want to test out the communication. Can we use a USB to RS485 converter on our notebook with Workbench?
If you can get that, yeah, if you can get it to map to a COM port in Windows, then you can try it. Nothing's guaranteed because it comes down to does Windows, is Windows going to play the game and work for you? Yeah. So yeah, right. It's an option, but it's entirely in the Windows world as to whether it's going to work or not. Whereas with an FX80, yeah, that's the one thing that an FX80 does that a Windows station doesn't, is an FX80 has got COM ports and is set up to use those COM ports, and all of that is guaranteed and works. Whereas running a station inside a laptop, a Windows laptop, there's Windows sitting between you and the COM port and the mapping of that COM port. And so you can get it to work, and it probably will work, but there's a chance that it won't. If that makes sense.
Yeah. Yep. We're at the mercy of Windows. That's
right. Yeah.
One more question. Is there anything to be concerned about the half duplex and the full duplex configuration?
So Modbus is half duplex. So particularly on RS485, it's half duplex. So only one device on that trunk can be transmitting at any one time. So the FX80 is the master. All of the other devices are the slaves. And so the master sends out a request to a particular device, and that device replies. So the master polls, and the slave replies. Okay? And so if you're a slave device, you just sit there listening. When you see a message with your name on it, you read it and respond to it. If it doesn't have your name or your address associated with it, you just ignore it. So if you're a slave, you just listen and reply. If you're a master, you send out a request and you wait for a reply. Okay, and so that's half duplex. You're only ever one device is transmitting at a time. And it's either the master making a request or the slave replying to a request. And so that means that if a device is offline, the master will poll it, send a request, get no reply. You'll have to wait, time out, try again, wait, time out, try again, wait, time out, and then flag that device as offline. And so if we look up here at our Modbus trunk as our property sheet, there is some maximum fails until device is down. So if I have 2 read failures, if I poll it and it fails 2 times, then I mark it as down or offline. Okay, and the response timeout, I'm going to wait 1 second to get the reply back. Okay, if I don't get a reply back in 1 second, I'll try again. Get no reply, I'll now mark the device as down. Okay, and then somewhere else in here there is another poll scheduler that says where is it? The ping monitor is 5 minutes. Okay, so if a device is offline, every 5 minutes I'll try again to see if it's online. I'll ping it again. I'll read that ping register and wait for a reply. Okay, so that's good. That means that it takes me 2 seconds to work out if it's online or not. If it's offline, in 5 minutes time I'll try again, and in 5 minutes time I'll try again. But that means that if you fix the device is offline, you go and check it out, turns out it was turned off. I turn the power on, I might have to wait up to 5 minutes before it'll come online. Okay, because it has to wait for this timer to time out before it tries again. And so if you're on a project where you've got a lot of devices offline and you're working through fixing them and you want to have a quick turnaround to see whether they come online or not, it might be worth changing that timer down to 10 seconds or something. Okay, particularly if there's only one device that's offline and you're trying to work out why he's not coming online, then setting that down to 10 seconds means that the master will be regularly trying to get that device online. Okay, once the job's in, working, settled down, stable, you could put that back out to 5 minutes, because it then means that if a device fails, you're not continually trying to poll it, because every time you poll it to see if it's online and it's not, it takes up 2 seconds of communication time, because while you're sending out a request, waiting a whole second to get no reply, send it again, wait a whole second, 2 seconds has gone by before you move on to the next device. Okay, these are in this same section. So this is up on the network, your poll scheduler. This is where you nominate the fast normal and slow pole rates. So the fast is 1 second, the normal is 5 seconds, and the slow is 30 seconds. Okay. Once the trunk is up and running and working, you'll get an average pole rate in milliseconds, which is the time it takes to poll every device on the trunk and get back to the beginning. Okay, so if the normal poll rate is 5 seconds, but the average poll is 10 seconds, then that's okay, but it just means that it could be 10 seconds between a point contact's closing and you see that contact closure on a graphic. All right. And for Modbus, there's nothing you can do about that because that's just the nature of a Modbus network. You poll the first device, you poll the next device, you poll the next device, you poll the next. You just go through the whole list of devices, one after other, then back to the beginning. The fast poll rate lets you concentrate and poll some points more quickly than others. But if you make every point fast, you'll be back at 10 seconds, and they'll, you still can't, you won't improve the total throughput. Okay, and by fast polling some points makes the other points slower. Okay, so you shouldn't really worry about slow and fast polls unless you have to. You should just leave them all as normal because that will give you the best performance for all your points. And same with these statistics here, normal polls 98%, so 98% of the points are in that normal poll list.
Hello, David.
Yeah.
I have questions on, is it how the TCP/IP Modbus gateway integrations look like? Is it similar like those creating the JCI stations, or there's another way around?
Yeah, so Modbus TCP/IP is very, very similar. Now, when we did our new station, we had the choice to also define a Modbus TCP network. We didn't do that, and now we're got the job, we're halfway through, and it turns out we need to add a Modbus TCP network. Okay, so to do that, so to add a network, we can go to drivers, and we're in the driver manager. We can go new, and we can choose Modbus TCP network. Okay, so Modbus TCP network. We go OK, and we'll just call it, we'll leave it at that. And there we've created it. Okay, and first thing we do, if we look at the property sheet, we've got all of the same sort of stuff, but when we can create folders just like we could for the normal Modbus network. When we add a new device, Modbus TCP device, we can go OK, And it's just like the RTU device. It's got a ping address and it's got a device address, all right? And it's also got an IP address. So 192. Yeah. And it's got an IP port number that it's going to use. Okay, and so that you need to know the Modbus slave that you're trying to connect to will have an IP address, you'll have a port number, and you'll also have a device address. Now that device address might be just one, but it could also be something other than one. But you've got to have those three pieces of information from the device address, the IP address, and the port. Okay, and then from there, everything else is the same as RTU.
David, what
Yep.
if the Modbus IP slave device is in a different network? Can we use the second network port of the FX80 to be configured for that, or we need another way?
Yeah, so you've got two IP ports on the FX80, and that allows you to connect to two separate IP networks that are completely different. Okay, and so you need to make sure that those two IP networks that you connect to have got different subnets. Okay, so if your first one is 192.168.1.149, you cannot use the second port to be 192.168.1.150. It can't be in the same subnet. It has to be a completely different IP address. Okay, so you can be set up with two IP ports, each with its own IP address, but the IP address has to be different, significantly different. They can't be in the same subnet. And what happens then is that when you say IP address 192.168.0.100, the FX80 knows which IP port to use because it'll be the IP port that's in the same subnet as the target. Okay, so if I had .0.149 as my IP address, then that's the IP port I would use. The other IP port would be set up as 192.170.113.5, then the FX80 knows that that IP address cannot be accessed via that other port. So yes, you can. And when you set up this TCP network like we did, we didn't actually get to choose which port we were using because that decision is made based on the IP address of the target. So you noticed in that when we go look at the property sheet for this IP network, there's no link. There's no point where we say this is the IP port that we're going to use. It's not in there. When we compare that to our BACnet network, we had BACnet.com network IP port. In here, we actually had to choose which Ethernet port to use. Okay, and that's the nature of BACnet IP, that you have to do that. For Modbus IP, you don't have to do that. But you do have to make sure that your two IP networks, if in fact you have two IP networks, that they are, the IP addresses are significantly different in the two networks.
Hello, David.
Yep.
About the TCP/IP Modbus.
Yep.
Say if we have a third-party Modbus gateway,
Yep.
does it mean that you need to sit relying on the FX80 itself, or we can be directly switched out from the network switch and then we just use the FX servers to configure same level as the FX80?
Yeah, so the Modbus TCP network can be in an FX80, but it can also be in an FX server. Okay, so you can set up an FX server to have Modbus TCP IP connected Modbus IP devices coming into the server directly. You do have to have a device license for each Modbus device you connect to, and the point count matters. So the points that you map out are all included in the count. So yeah, you can go directly into the server. Does that answer your question?
Yes, David. So
Yep.
does it mean that the original free Modbus license that's only limited under the FX80, if we sit on top of the level of the FX server, we need to purchase additional license for the Modbus, right?
So the license, so every station, right? So a station which is running inside a platform, so the platform and the station go together. The station has networks, okay? If the station has just a Niagara network, then it's an FX server, right? So a pure FX server has just a Niagara network. And on that Niagara network, it has 1 or 2 or 3 or 4 or 100 or unlimited number of Niagara devices that it's communicating to. Okay, so that's your standard FX server license, is how many devices am I connecting to on my Niagara network. If my server has a backnet network or a Modbus TCP network or some other IP network, then now that server is bringing in IP devices, not Niagara devices, IP devices into the server. So for that, you need a device license to cover those devices and points that you're bringing in. Okay, if all you're connecting to is FX80s, then all you need is the Niagara license to cover that. If those FX80s are going out and connecting to Modbus or BACnet, IP or RTU or MSTP, doesn't matter. Doesn't matter what the FX80 is doing. When it talks back to the server, it's a single Niagara connection and it's covered by the server. Down at the FX80 level, you have to have the device licenses to cover all of the things that you've connected to. Whether you connected through a COM port or through the IP port, whatever you've connected to, you've got to have a device license for every device and enough points to cover the total points that you've mapped through those field devices.
All right, David. Thank you.
Yep,
David.
that makes sense. Yep.
Yeah.
David, I think there's a question in the chat. How many
Yep.
protocols are allowed running in the FX80? By, I guess, how many integrations we can define?
Yeah. So you can, so the limit is the number of physical ports. So you've got 2 as standard. You can put expansion modules on to get 4 more. So you can get a total of 6 RS485 ports. And so you could have 1 BACnet MSTP, 1 Modbus one or 2 Modbus, 3 Modbus, 4 Modbus. So the number of physical ports is a limit, and the other limit is your device license. So you can have all of the available protocols into an FX80, provided you've got enough device licenses to cover all of the devices that you've mapped. Okay, so when it comes to actually trying to decide or design what do I need to order, the first question is, how many devices am I going to connect to, right? And you've got to get that device count, you've got to work it out and get it nailed down and defined. How many devices am I going to connect to? Because that determines the device license that you purchase. And the point count matters, because if you connect to a Dakin VRF, you'll have a single backnet IP connection to the Dakin VRF, but every indoor unit that you map to is possibly going to bring in 10, 20 points, just say 10 points. If there's 100 indoor units, there's 1,000 points there. Okay, so if you're now looking at 1,000 points, not just one device. So you've got to have at least a 10 device license. What, 10 devices gives you what, 500? So you need more than 10 to get your 1,000 points out of a single Dakin backnet device. Yeah, so the point count matters, the device count matters, and whichever limit you hit first is the limit that matters. But you can also have a situation where you've got a Dakin VRF system with a single backnet connection and 1,000 points, and then you might have 20 M-bus meters where you're only reading 1 point out of each meter. So a 25 device license will cover you. 20 points for the M-bus meters, sorry, 20 devices, the M-bus meters, plus 1 device for the gateway, for the Dakin backnet gateway, and then 25 devices is what, thousands of points. So yeah, away you go. Does that make sense?
Yep.
Okay.
So,
I have a question, David.
okay.
Yeah.
Can I have a 2 comport standby in one FX80 for the Modbus?
Have 2.
And switch between when got problem.
Sorry, say that again. Can you have 2?
Modbus comport in one FX80.
Yeah.
For example, if I'm using the COM3 as a Modbus,
Yep.
then I get another expansion module
Yep.
for standby comport. Then after that, if my COM3 got problem, I can switch between another COM.
Yes. So if I had 2 Modbus RTU networks,
Yeah.
I would have this one, and I can duplicate, and now I've got my second one. Okay, and it just happens that I've duplicated all of these devices as well. Now, if I look in here in my property sheet, I've got my link, my serial port configuration. I just need to change that to COM3. Yeah, so this one was COM2, This one is COM3. If for some reason, this COM port gets damaged, not working, I can come in here, change that to COM4, save it, it'll start polling out COM4, provided I'm not using COM4 for something else, yeah?
Mm-hmm. Okay, thank you.
Yep.
Coming back to the earlier question on how many protocols, so for example, I can, on one IP port, I can have BACnet IP, Modbus IP, KNX IP, there's no issues.
That's right. So, yeah, so the IP network is different from the RS485. The IP network can allow lots of different protocols, all sharing the same network. And what's different is that every IP address has a port number. So, so when I set up this device here, his address, where was it? Here, his IP address and his IP port. So those two things together, so you could have, like in practice you never would, but you could potentially have a super device that does both BACnet and Modbus with the same device, and it could exist on the same IP address, but the Modbus would be communicating on port 502, and the BACnet would be communicating on the BACnet port, the 8084 or whatever it was. Yep. So the reason you can have different protocols all operating on the IP network is because each of those protocols is using a specific port number. And the port number, so you have to keep track of your port numbers and make sure that you're not clashing on port numbers. Yeah. So that's our Modbus network done. The other day we asked about the N2 bus. Okay, so we don't have N2 on here. In our new JCI station, we get the choice to select N2 as one of our protocols. If we didn't, but we want to add it later, we can come in here, double click on drivers and add a new network and choose JCI N2 network and go OK. I will just call it N2 bus in this case. There's my N2 bus. It's been created. If I right click and view the property sheet, we've got our serial port configuration. We choose a COM port. So we're up to COM4, I think. The baud rate is always 9600. You can't change that. The data bits, stop bits, all of this is fixed. Okay, we save that. We've now set up our N2 bus. This one's failing because that COM port doesn't exist. But on an FX80, it would now be polling out on that N2 bus. Double click. And we get the N2 device manager. Okay. We do have the option to discover on the N2 network. And what that will do is it'll go out and poll each of these addresses from 1 to 255. And if there's an N2 device out there, it'll reply back with its device type. So you can go out and discover all of the N2 devices, and what you'll get back is the address and the type of device, whether it's a VAV or an AHU or a VND or a DX9100. But that's all you will get. You'll get the address and the device type. You've got no idea whether it's where it's located, what it's called, what it does. All you know is the type of device and the address. So you can discover them. You can also go new and create a device. And your choices are VMA, which is the old VMA 1400, or a DX 9100, or a TC 9100, or an XTM, expansion module for a DX, or if it's a VND or any of these models, they all get covered by the one type. Okay, so I'll make one of those. And these are type N2 open. Okay, and it has the address which is set on the dip switches of the controller. We go OK. I've now created my N2 device. He's polling out to address number 1, expecting a reply back saying he's there. It appears a lot like a Modbus device. It's got a folder for points. I double click the points and I don't get to discover. Okay, so N2 is like Modbus. For N2, you must have a mapping table. So if I just say this was a Danfoss BSD, and I went Danfoss N2 mapping table, the supplier manufacturer has to create this mapping table, and as we go through here we will find it. Analog input AI. So let's see if we can get something useful out of this. Here it is. So AI1 is the reference. AI7 is the kilowatts, is the power in kilowatts. AI8 is the horsepower. 9 is the voltage. So the frequency is AI4, okay? And somewhere in here, this will be a VND device. Because it's a third party, not a Johnson Controls, it'll be VND, which is what we chose. So this, we can rename him as Danfoss BSD01. We can go to our points and our point details manager. We create a new point, a numeric point. and it was going to be frequency and the point type and the point address. So its point type is analog input, the address is analog input number 4. Okay, the frequency in hertz is 4. So AI 4. Okay. And if we look at the property sheet, it's got the facets again. So this time we want to set the units will be in for frequency, hertz, okay, 1 decimal place, and away we go. And in here we've got the network point type and the network address. Away we go. Yeah. So without that mapping table, you've got nothing. You've got to have a mapping table. But once you've got it, away you go. Okay. So there are your analog inputs, binary inputs, analog outputs for commanding, binary outputs for commanding. Okay, so there's anything else about N2 that you're...
Yeah, David, one last question.
Yeah.
If I can discover the N2 device, but I cannot show online, is it the FX server got built in, like the Modbus can ping the device?
So when you go in N2, when you go discover,
I can get the
so the N2 protocol has a message which basically says, what's your type? It's just a message that says, tell me your device type. And so the discover process is it just goes to the first address, sends out that message, and waits for a reply to come back. If it gets no reply, it tries the next message, next address. So it does that 255 times. It gets 20 replies come back, and it knows which devices replied and what type they were. And so if you do that to a working N2 bus, you'll get a list of all of the N2 devices that are out there and powered up and working. Okay. If they don't come back, if you don't see them, you can still create it and create a new device, but you need to go and investigate as to why it's not replying.
No, my question is, I see them, but at the station they show offline.
So you discover them.
This is my biggest problem. I can discover it, I can see it, but I cannot make it online.
Okay, so it's discovered up and it appears in this list up here.
Yeah.
Yep. Then you select it and you go new or add. Sorry, the add button should come up, and you add it down here. Yeah. So you've gone that far. You've got them listed under database.
Yeah. But it's so fast.
But they're saying that they're down, offline. Is the NAE still connected to the N2 bus?
Yeah.
Yeah, that can't work. So
Yeah.
an N2 bus is a slave, master-slave network. So there's one master and everybody else is a slave. So if the NAE is connected, then the NAE is trying to be the master and he's polling out and they're replying to him. If you come and plug the FX80 into the same network at the same time, then the FX80 will start polling out, expecting a reply back at the same time. The NAE will poll out expecting a reply and you'll just get a mess and they'll both break, right? So you can only have one master device at a time. So the test is you unplug the NAE and you plug it into the FX80. You can't have them both connected at the same time.
Okay. Okay.
So if you do that, it should come online and work. And now you need to change the connection as well because the 3-pin plug on the NAE is different to the 3-pin plug on the FX80. The plus and the minus are swapped over, I think. So,
But actually, my question is, my concern is if I migrate to FX80,
yep.
what it means is when I discover the FXPCG, but I cannot make it online, is it any way to troubleshoot? Is the connection problem or the PCG a problem using the workbench? You got my question?
Yeah.
Because previously I just changed the device address and it's successful online. So I'm not sure is the device problem or the workbench communication problem.
So when you say you changed the device address, did you change it in here?
It's online.
Or did you, so,
for example, my device address is 4. Then I can discover it. I add it, but I cannot show online. Then using the metasys, I cannot troubleshoot it. So I just try my luck to change the address, become 6, discover it, and become online. So is it possible on FX server can make a troubleshooting on this kind of problem?
So it's this. It's very simple. Like you just have to have the right address and only one master.
Yeah.
So like it's a very, very simple protocol. If you have 2 devices set to the same address, they will not work.
Yeah. Definitely no duplicate address.
That's right. So you gotta have but other than that, if it's wired correctly, it'll work. Right? It's very simple. So yeah, what have we got? There's in the property sheet for N2. Yeah, there's really not much to look at. Into property sheet. So there's this in the poll scheduler. You should see some statistics about polling. But yeah, health, what does that do for us? Yeah, it's a very simple protocol.
Okay, I got it. Maybe
Yeah.
it's good to have the feedback from the
Yeah. So
response timeout. Yeah, I can troubleshoot from here.
yeah.
Okay.
So there's like one. You know, you can, if you can connect to just one device with a single cable from your FX80 to one N2 device with nothing else connected, then if you can get that to work,
Yeah.
then you can work at getting everything to work. So it's sort of like, best case is you unplug it out of the NAE, you plug it into the FX80, and it all comes online and works.
Okay.
Right.
Thank you.
If it, yeah, and that's, you know, that should be what happens. Yeah.
Hey, David.
Yep.
Yeah, Ardian speaking.
Yep.
Yeah. In Jakarta, I think so many requirement about the billing system. If we're
Okay.
talking the billing system, so almost all of the device using the Modbus device, right?
Yep.
Yeah. My question is, actually, can the FX80 is implemented to the billing system?
So you can set up a network of Modbus meters. You can read the meter values. You can set up a trend on those values to sample them every day, and you can collect all that data.
Okay.
But it's just like a normal BMS, is that you've got all that data. If you want to actually do something with that data, then it comes down to what do they mean when they say billing system?
Okay.
Right. So.
Okay. So we can collect the data day by day, or okay.
Yep.
Okay.
And you can create a graphic, or you can create a report that lists all of the trend data, like the daily totals or the monthly total. So you can get all that and present it as a graphic, or you can present it, and once it's there as a graphic, you can export it as a PDF, or you can export it as a CSV. So you really need to get clear what they want.
Okay. Sometimes customer asking us to show data until the pricing, right? Can the FX80 interface with the other software in order to we can show the from data we change to the price?
So it depends on what system it is that we have to connect to, and how are we going to connect, and what's the protocol, and so like it's a very flexible system. You can do just about anything you need to do. It's just you have to do it. Yeah, it's
okay.
Yeah. So
okay.
Yeah, it's.
I think the main point is we can show the data, the like the energy meter by day to day and day to date or month to month, right?
Yeah.
Okay. This is the matter point. Thank you, David.
Okay, good. All right, so that's probably, we've gone past our finish time for today. So the plan is for next week, we will do the same type of thing next week so 2 days, Monday, Tuesday, then Thursday, Friday. And these are the topics we plan to cover. So on Monday, we'll talk about automation using wire sheets and schedules. So basically how to just to do automation in the FX80, how to do interlocks, how to do calculations, how to command things on, command them off, and so on. On Tuesday, we'll talk about graphics. We'll go through graphics. On Thursday, we'll do point extensions. So alarms, trends, totalizations, and that one's, we won't do that. That's for the graphics. And then Friday, we'll go into detail on setting up a Niagara network on an FX server. So connecting to an FX80 and what does an FX server look like when it's talking to Niagara devices? Yep. So that's all next week. And then depending on how we go, we may have a session the following week just to finalize everything or not. So let us know if there's things you want us to, if you want us to go faster or go slower or more detail or less detail, then let us know. But that's the plan for next week, the same time, and I'll send out the links hopefully today. Later today, I'll send the links for the teams. Okay. So yeah, that's it for today. And unless there's any more questions, we'll stop the recording and we'll see you on Monday.
Okay, thank you, David.
All right, thank you.
Okay, thank you, David.
Okay.
All right, thank you.
Thanks.